All right, welcome e-learners. Hey, quick note, class. Starting on Monday, I'm going to be broadcasting live. Like, the kids will be in the class if they choose to. Just so you know. You don't have to dress up or anything like that.
What do you mean? I gotta like shave my little goatee.
All right, everybody has a piece of paper, yes? You need to have a piece of paper and a pencil. Now, normally, you guys listening? Normally, I'm going to hand you a sheet of paper that has little boxes on it. And for those of you that had me before, you know how that works. Today is a different class. Normally what happens is the very first thing we'll do, I'll say, get out your homework. There'll be a slide that says what your homework was. I'll say, get out your homework. Any questions? Yeah. I will just tell you today, this year in geometry, I expect every single class period, someone is going to say something, I didn't get this one, and I'm super confused, right? The amount of times that you will be super confused is large. What I need you to do when you do your homework is, if two problems are exactly alike, you pick one. We won't be doing two. But trust me when I say, every single class period, last time we might spend 5, maybe, 7 minutes on it. We'll be spending 10 to 15 minutes each day just going over homework typically. It'll be rare, unless you guys don't do your homework, it'll be rare that we don't spend a lot of time on homework. All right. We talked about this yesterday. You got to have the ability to click, focus, right? Today's a very simple, no one's going to be confused at all today. Today's 3/4 is a history lesson, just a little bit of time that we're going to spend with the tools of geometry. We ready? All right. For those of you who have me, you know what this is. Top row is the week that we're currently in, right? If you didn't remember, you didn't come to school Monday or Tuesday. There was some of you took a placement test, some of you didn't. We did the intro yesterday. Chapter 1, section 1 today. Okay. All right, quiz next Wednesday, and then we got a test. Now, I will say this. I've been teaching geometry a long time. Some classes can easily digest some things, like we'll make great progress. Other classes, I may say, we're going to do this whole lesson today and find out, wow, we didn't get anywhere, right? This will be, I had you guys, what, pre-algebra or algebra 1? Pre-algebra, right? We never once had a lesson where I didn't finish. This happens all the time, many times in geometry, where I'll be teaching and we don't get through the whole lesson. I'm not saying, hey, let's ask Mr. C a whole bunch of math questions so we don't have homework, right? That sort of thing. But be prepared that there might be days where I don't get through the whole lesson, right? Justifiably so. If you're confused, we're not leaving with you confused, especially in geometry. So even though it says next Wednesday is the quiz, we get confused on 1, 2, 1, 3, probably not. Things can shift. Okay, click, darn you. I don't know why it doesn't click the first time. I'm not sure. All right, am I on the right? Hold on. Yeah, no, we're good. Okay, introduction to geometry. Like, isn't that what we did yesterday? Yesterday, the purpose of yesterday was to show you that we did good math and we got to a ridiculous answer. Add up all the numbers and we get -1/12. You paying attention, right? That was a ridiculous answer. And what I left you with is that geometry is the course where we prove everything. We accept nothing. The teacher isn't right. The math book isn't right. It's only right if it can be proven to you. Okay? All right. So literally the objective is you got to use your compass and your straight edge to be able to measure things. That's it. All right. Geometry, some definitions. I'm not having you write this down. Typically, starting on Monday, we're going to be writing down a lot. Geometry, anybody know? What's it mean? What words do you see? Geo. And then metry, right? So geo is geometry comes from the Greek word metron, right? Geo means the earth. Metron means, take a guess, it means to measure. So what is geometry? You're measuring the earth, not literally, but you're measuring things that exist on the earth. The table, right? How large is the city, right? All of those are geometry, Micah. Pay attention, please. Okay? And if you can't resist the urge to touch those tools, then put them down and pay attention. All right. Officially, we define geometry as the field of mathematics that describes, defines, and measures physical objects. You're like, yeah, I know that. We've been doing that since second grade. They gave us, I don't know, a rectangular prism right here, or a triangular prism, and you figured out the surface area, the volume, right? You've been doing that for a while. And I told you yesterday that actually the high school course called geometry is more about logic and proving things. Yeah, we're going to measure all those things. But what we're really doing is proving things and learning how do you determine if something's true or false. All right, quick interesting fact. Arithmetic was the first math ever invented. Guess what the second one was? It wasn't algebra. It was geometry. Geometry is the second math that was, quote, quote, invented, right? All right, a quick history lesson. The Indus Valley is one of the big river systems, right, in India. The Babylonians, that's what we basically call Iraqis, right, Mesopotamia, that sort of thing. So here's India right here. Here's the Indus River Valley. The Fertile Crescent, right at the start of Iraq, where the Tigris and Euphrates come together. We give them credit for coming up with the first math and the first geometry. Because this always flooded all the time, these valleys, right? And they had property, and they had to figure out after the flood, well, where's my property? It just flooded, right? All the boundaries have gone away. So they had to use geometry. Chris, put the compass away, please. They had to come up with a math system to allow them to do these measurements. So they were concerned, and they were interested in things like lengths, angles, areas, volumes, that sort of thing. Okay? It was developed by, it's a practical method, right? For practical needs. They weren't dealing with just, hey, what ifs. They were dealing with, hey, I need to measure this land. I need to know when the sun is stopped moving upwards and it's going in a downward direction on a daily basis, the seasons, that sort of thing. Right after that, the Egyptians were the next to advance this field called geometry, right? We always know that the Egyptians are famous for the pyramids. Obviously, that's a pretty darn nice geometric figure right there. They were kind of the same thing, but they were, because of the things that they built, they also really advanced the field of mathematics in three-dimensional objects, right? But once again, they were more focused on the more practical things. Surveying, construction, and astronomy. All right, and then boom. Right. Who came next? The Greeks, right? The Greeks were the next. And I am not being facetious when I say, boy, did they have a big boom, right, in geometry. They literally wrote the book on geometry. Literally. Here it is, right here. This is the book that the Greeks wrote on geometry. There's no difference between that and your book. It's the same book. You are studying math that is, 2,500, 3,000 years old. Right? They wrote the book on geometry. This is the book. It's called Euclid's Elements. We'll talk about it here in a second. All right. They were concerned with three things: truth, perfection. If something's true, it's perfect, and the Greeks considered that to be beauty. Right? We look at Greek buildings, we say that's a pretty beautiful building. Why? It's perfect, right? The math behind it is perfect. We look at their sculptures, right? And it's not the the ancient way of sculpting where it's like, yeah, I think that's a woman. You look at a Greek statue, that's a woman, that's a man, right? It's showing the body in correct proportions, right? It's beautiful. We consider even now. We consider their art beautiful. All right, they were primarily interested in truth, and that's what geometry is interested in, is truth, right? I'm not going to say, trust me, this is true. I'm going to prove it to you this year, almost everything, that it's true. All right, they were concerned with proving something's true, and that's why in geometry we do this thing that most students do not enjoy it. Some students do. I was one of them. We do this thing, it's called a proof. It's how we prove things, but we call it in geometry, hey, How many proofs did Mr. C assign us tonight? I hope it's none. No, he gave us 2. Oh, my life is horrible. I got to do 2 proofs. Okay? All right. The main person, or one of the main person in Greek, the field of geometry, was this guy named Euclid. He actually lived in what we would consider Egypt, in a place called Alexandria. That's why he's called Euclid of Alexandria. Jay, are you going to make it? Now there's Alexandria. It's right next to Cairo. And that is his book right there, Euclid's Elements. Okay, this is a famous Renaissance painter called Raphael. This is a mural. It's way bigger than this, but he's presenting Euclid teaching his subjects. I always like this guy because he's got these like lion socks on. Pretty cool. So this was painted by Raphael. There is Raphael, not that Raphael. So I do want to say this was painted right around 1500, like 1492. 1492, what happened? Christopher Columbus. The story is he didn't know the world was round and blah, blah. There's a globe right there. Raphael painted this right around Columbus's time. They knew the world was round, right? And there's a globe, and it actually shows the continents kind of close. They didn't have a good idea of how the size of the continents, but it's a globe. So don't believe the when they tell you that Columbus didn't know the world was round. He knew the world was round. This was the actual book, Euclid's Elements, right here. There are 13 chapters or sections of his book, and so sometimes it's called the 13 Elements. Your book contains the 13 elements. Your book is very similar to his, right? This is a quote from Euclid, The Laws of Nature, about mathematical thoughts of God. And I don't want to make this a religious class, but he literally said that you could explain the universe. He considered the universe created by God. Therefore, the universe was just an expression of mathematics. Most people, most scientists, that are religious would all say that math is the language of nature. We explain nature. We want to prove something. We reach to mathematics to prove things. We explain everything there is in nature through the field of mathematics. Therefore, Euclid is considered the father of geometry. He wrote the book on it. Interesting enough, it is the most famous, literally, it is the most famous and most widely published textbook of all times. That book right there, Euclid's Elements. Your book is basically Euclid's Elements. Father of geometry. We call his math Euclidean geometry. You also call it plane geometry. It doesn't mean unadorned, right? It means flat. So this means geometry that you can draw on a piece of paper. You can draw it on a piece of paper. It represents, meaning 2 dimensions. And that's the kind of geometry we learn. We do a little bit of 3D geometry, but mostly we do what's called plane geometry or Euclidean geometry. He started his book with points. Guess what we're going to start with? Points, right? And he built up an entire math starting with just points. We will do the same thing. You're going to work on an entire system starting with points. The difference between geometry and all the other math that you had before is nothing's proven to you. They tell you that 8 times 7 is 56. They don't prove it to you. Euclid proves everything, and we will prove almost everything. There's a couple things that can only be proven using calculus, and you don't know calculus. All right, he had 3 things. He had definitions. We will have definitions. He had these things called postulates and common notions. We just combine them all. We call them postulates. These are just things that we accept to be true. We don't need to prove them. For instance, a right angle has how many degrees? And that's a definition. Right angles have 90 degrees. A postulate says that all right angles are the same. Duh, right? If one's 90 and it's called a right angle, then if you have another one that's 90, or a right angle, it's got 90 degrees. So these are things that we don't prove to be true, we accept to be true because I call them the does. Lastly, you have these things called propositions. We will call them theorems. Don't get hung up on the words. We're going to spend lots of time on the words. You'll be a master at this by the end of the first month. So back to Euclid and the lion socks. He's in awe of geometry. I'll just say, geometry makes me cry sometimes. Literally, it's so beautiful. Next to one book, it is the most published book of all time. Guess what that other book is? The Bible. The Bible is the most published book. That book right there, your book is also Euclid Elements. It's the second most published book of all times. Everyone in the world that goes to school studies Euclid, right? We consider you to be uneducated if you don't take geometry. And it's not because of shapes. It's because geometry is the course where you learn how to think logically and prove things are true. Later on in life, you're going to want things to be proven true. They have nothing to do with geometry, but you're going to use the things that you learn in geometry to accept things as either being true or false, right? I'm going to teach you how to prove things are true or false. This is a long quote. It's from Lincoln. I always read it. In the course of my law reading, remember Lincoln never went to high school or college. He taught himself the law by reading books, right? In the course of my law reading, I constantly came upon the word demonstrate. I thought at first that I understood its meaning, but soon became satisfied that I didn't know. What do I do when I demonstrate more than when I reason or prove? How does demonstration, a lawyer has to demonstrate that this person is guilty or innocent, okay? What do I do when I demonstrate more than when I reason or prove? How does demonstration differ from any other proof? I consulted the dictionary, right? They told of certain proof beyond a reasonable doubt. You've heard that as a legal term. But I could get no idea what sort of proof that was. I thought a great many things were proved beyond a possibility of doubt without recourse to any such extraordinary process of reasoning as I understood demonstration to be. I consulted all the dictionaries, the books, reference I could find, no better results. You might as well have defined blue to a blind man. At last I said, apparently he talked to himself, Lincoln, you can never be a lawyer if you don't understand what it means to demonstrate. So I went home, gave up being a lawyer. I went home to my father's house and stayed there until I could prove any proposition in the first 6 books of Euclid cite. Euclid teaches you how to prove things beyond a reasonable doubt, accepting as something to be true. And then I found out what demonstration, and I went back to my law studies. I mean, this is Lincoln, right?
Its first common notion is this: things which are equal to the same thing are equal to each other. That's a rule of mathematical reasoning. It's true because it works. Has done and always will do. In his book, Euclid says this is self-evident. You see, there it is, even in that 2,000-year-old book of mechanical law. It is a self-evident truth that things which are equal to the same thing are equal to each other.
What is he talking about there? Is he talking about math? We hold these truths to be self-evident, that all men are created equal, endowed by created by certain inalienable rights, those of life, liberty, pursuit of happiness. That's the Declaration of Independence. He's talking about slavery and why he's doing the Emancipation Proclamation. Where do both of those great men reach from? Lincoln and Jefferson. They reach back to Euclid to prove things to people. Right? This is why you're considered uneducated if you don't know geometry. And they're not really saying geometry. They're saying you're uneducated if you can't prove things. And that's what I'm going to teach you. And that's why I love geometry. All right. Everything I just said. So you ready?
Yes, sir.
You ready to learn how to prove things? All right, here we go. All right, some quick rules and expectation of the course, not of the class, right? These things right here, which right now, except for the word definition, should be, I have no idea what they mean. You will know. But we deal with definitions. Euclid had definitions. He had postulates and common notions. We just have postulates. And then he had I forget what he had, but we're going to do theorems and corollaries. Theorems and corollaries are pretty close to each other. And like I said, I just want you to understand that I'm going to be throwing some of these words out. You'll come to know what they mean. This is a hard one, and I say it to all my class. You got to be ready to fail. I don't mean an F in the class. I mean, you got to be ready to look at problems and not know what to do or not know what the answer. Half of you say, well, that's every math class I've ever taken, right? But you got to be ready to fail. Like you've made an effort and you really want to pass the class, and you look at a problem, you're like, I don't know what to do. That is common. This is why geometry is hard for many people. is that they're not ready to fail. You got to be ready to fail. But in doing so, in being ready to fail, you got to be ready to come back to the next class and say, how do you do this problem? I always draw this diagram. I'm not a mountain climber, but they had me climb mountains in the Army, right? And they call them routes up a mountain. They go, hey, which route are we going to take, right? Anybody climb or rock climb at all? Right? They call them routes. So I'm gonna draw. You're going up the mountain. So the mountain starts off nice and gentle, then it gets steep, and then it has this one little tiny part right here that's impossible because it's like that, and then it's nice and gentle to the top. This one little part right here is called the crux of the climb. And the crux of the climb is, I don't know how to get over that part. It's hard. I may not figure it out. All geometry problems are like this. You may know how to start, you may know how to finish, but you can't get over that part. It doesn't mean, well, it means you failed the route, but it doesn't mean that you failed the problem. It just means you don't know how to get past that. What will typically happen in geometry is that you come the next day and some kid will just blurt out, oh, it's just this, and you're like, I'm an idiot. How come I couldn't figure that out? That is a hard thing. I'm pointing to Seth, but that is a hard thing to get over. That crushed me so many times. Like, why is that kid, why did they get it and I couldn't figure it out? And I considered myself smart and I couldn't figure it out. And it took me a long time to, ego is part of it as well. It took me a long time to be comfortable with failing at geometry, right? This is the thing. You got to get ready to be stuck at certain parts, right? Some problems have, 10 steps to get to the end. If you get through the first 3 and you know how to get to the last 3 and you just don't know the middle part, good on you, right? But come to class the next day ready to figure out how to get unstuck from that one little problem. All right, everyone learns at a different pace. I will ask an open-ended question and somebody will blurt out an answer. And other people are like, come on, give me a chance to think about it. So I will give you a reasonable amount of time to think about something. You may still not know what the answer is. And I will call out, hey, who's got it? And they will say the answer, and you will feel like an idiot. Why am I so dumb? Why don't I get this? Because everyone works at a different pace. Right? I will try to keep that, having someone blurt out the answer to a minimum, but it happens in class. All right, ready? The rest of the class is the tools of geometry. So the first tool of geometry, who knows what it is? The first thing that you use in geometry, it's not called a pencil. They didn't have pencils in Greece. I've never been fully told. I believe they did a lot of stuff on the sand, right? Like they would draw things. They had slate and things, but a lot of stuff was done in dirt. Yeah, so what we are going to use is this thing right here. This is not a ruler. This is called a straight edge. Why? Because it's straight, right? We can go into a whole discussion of how to make something straight. But yeah, straight edge is the first tool. So that thing right there, it is not a ruler. It's called a straight edge. Now, yes, most of you actually have a ruler, or maybe you have a protractor. We will not use this, by the way, in class. We will use the straight edge portion. But this is what you're using. You're not looking at the numbers. You just need something straight. Okay? So that's called a straight edge. What do we use a straight edge for? What do you think, Karis? What do you think? What do we use it for? If it has no numbers on it and it's straight, what possibly could we use it for? Draw straight lines. That's it. Right? So it's not a ruler. Right? You can use it. You can use a ruler, right, if you have one, but we don't use it to measure. We do not measure with this thing. We measure with other things, right? So we're just going to use it to draw straight lines, right? Or objects. You draw a triangle, right? 3 straight lines. Now, I'm using imprecise language right now. We'll talk about the difference between segments and lines later. That thing is called and guess what we use a compass for? Circles. Absolutely not. We do not draw circles with this thing. Guess what we use this thing for? This is what you measure with. This is a measuring tool. It's not to draw circles. Okay, I'm lying. You can draw circles with it. But it is used to measure. Everyone would say, whoa, I can draw a circle. That's not what its intended purpose for. Its intended purpose is to accurately measure things. Like, wait, what? There's no numbers on it. Some of them do have numbers. Okay, so yeah, you can draw a circle with it, but it is used to measure objects. Okay, some compi, plural, right, don't even have lead on them. Like you can't draw with it because it's used for measuring. Anybody have one of those? Sometimes a kid show up who has no lead on it. Okay. Old paintings, right? This is from Byzantine era. It's Japanese, right? Notice what they have in their hands. What do they got in their hands? Well, this looks like a right angle, and it is, right? But it's a straight edge. And there's your compass. Straight edge, compass. Up until recent times, this is what you had when you went to geometry. You did all of your geometry with just a compass and a straight edge, right? Yeah. Thank you, Chris. You get it?
I know, I didn't know.
We use a compass and a straight edge to construct things. We make things with them. We draw things, but you can't make frames. This one's got a sharp, pointy edge, right? All right. We will use this tool today. You will use the straight edge nearly every day. The compass we won't use again until chapter 10. So we'll see. We're going to use it right now. And then chapter 10 is when we do this thing called constructions. We make things. Some geometry books do the constructions throughout the book. Ours puts them all into one chapter. I personally don't like that, but the way they write it, I have to teach it that way because I can't throw it inside because they use some other, I'm getting off track here, but trust me when I say I prefer a book that they do constructions throughout. All right, let's just do a couple and we're done. What time we get out of here? A minute or two? 54. All right, so plenty of time. We've got 6 minutes. All right, so here's what I want you to do. On your piece of paper, yes? Put a dot. There's my dot. Put another dot. There's my dot. How many dots you got?
2.
Okay, guess what I'm gonna say next?
Another dot.
Nope.
A line.
Connect the dots. What are you gonna use to connect the dots?
Straight edge.
Straight edge. So take your straight edge. Neatness counts. And play. Connect the dots. Now, next class I will tell you what you made. Most of you know, but I will tell you what you made. That's how straight edge is used. Did we use it to measure? Heck no. You don't measure with a straight edge. You draw straight lines. All right, congratulations. You did your first construction. Ooh, I want to use the compass now. All right, let's use the compass. What did I say the compass is used for?
Measure.
Let's make the same thing. We're going to make the same thing, but with the compass. So here's what you do. Grab your straight edge. Yes? All right. Somewhere on your paper, use your eyeballs. I want you to make that, to make it longer with the straight edge. You don't need to put dots. Just make a line that's longer than that. Okay? Now, be careful. Compass, what do we use it for? Measure. So guess what we're about to measure? The original one. Remember, we're going to make a duplicate. So one end goes on one end, and your other end, open it up, measures to the other end. You should, some have a locking mechanism, right? Some you just got to be careful with. So I locked it down. So now, from here to here is how long that thing is. Guess what I'm going to do with it?
The other one.
How am I going to measure the other one?
Putting your compass on it.
I'm going to take the pointy end and put it on one end, whichever one floats your boat. Boom. On the other end, you should have a drawing implement, piece of lead. I'm going to mark where it would intersect the first one. Everybody see what I just did? Guess what you just made? If I put a dot where these two intersect, all right, you guys do have rulers. You can measure. This one for me, I'll do it in centimeters. This one for me is 39 centimeters. And now from here to here is exactly 39 centimeters. I just made, if I erase the other part, I just made a duplicate of this. That's what the compass is used for. Is it used to draw circles? Could be, but it's primarily used to measure things. Who's lost? Like, geometry's easy. Yeah, if only the rest of it was like today. All right. All right, who wants to draw a circle? Right there. So we'll draw a circle. Okay, so to draw a circle, first off, well, how big do you want to make your circle? Pick a number, somebody. 2-inch circle. So now you do all have a ruler, right? Yes? Here's what you do. You're going to take your compass. You're going to take your ruler. You're going to open it up from this end to this end 2 inches. So how do you do that? Well, you got your ruler right here. 2 inches is too small for me, so I'm going to go under 12 inches. So I put it on 0, and then I open it up using the ruler and the compass to 12 inches. See what I'm doing here? I know this is horrible. Right? I got a 12-inch measurement. This is called a 12-inch radii right here. And then, guess what you do? You just put it right here, and you draw. Now this is going to be a circle with, right? This is going to be a circle of radius minus 12. So diameter of 24. Now notice, these tools are not very precise. Notice my circle didn't come out perfect. So if you want to be really precise, you've got to be careful when you use this, right? Who's lost? All right. So what do we do today?
Your lines.
Any lines? What else? Big circles. What else? What's the purpose of geometry? To prove things. Geometry is how you learn, how you prove things. Yes, it's about shapes, measuring the earth, but it's really teaching you how to prove things. All right. What would a great teacher give you tonight for homework? Nothing?
A circle.
Right. Oh, for those of you that want to draw a circle there, I blew your mind. I told you that the compass is for measuring, not for drawing circles. All right. A great teacher, you said, would give how much for homework? Who's saying nothing? All right. Starting next class, I'll end this right now. Hey, it gets way more challenging than what we just did right there. All right, that was just an intro class. So starting next class, it's going to get really challenging. You got to be ready to fail, but you got to be ready, more importantly, to try, right? The math, don't stop putting your stuff away. The math itself, like hey, adding, subtracting, multiplying, dividing, the computation is ridiculously easy. It's going to be literally 2 plus 7 or 10 minus 4. That's the computation. The geometry is hard, right? So the difficulty comes in the proving part. I don't care. You want to have a calculator the entire year? I do not care. Trust me when I say it's just not going to help you, right? I'm not saying, oh, I'm going to show I'm better, not have a calculator. If you want a calculator, use a calculator. If you have to use a calculator, do 10 minus 4, and I'll let you finish that sentence, right? But I'm just saying, some kids are like, you can use a calculator, right? If that gives you pleasure or that gives you confidence, use it. Any homework, any quiz, any test. But trust me when I say, that's not what's going to get you a C is having a calculator, right? You've got to be able to think. All right, so calculators are always allowed, not on a state test. You got to have a notebook. Everything is open notes. Everything is open notes. No open book, but open notes. It's the only math course we do like this. And you'll see why. We're on theorem number 642, right? You're not going to memorize 642 theorems. They're going to be in your book. And you're like, oh, I remember that was chapter 1. Oh, yeah. And they have numbers to them. That's going to be theorem 1.6, something like that. So, yeah, everything's open notes. Homework every night. Read it. Read it. Somebody out loud.
Homework every night except test nights, Christmas, break, and today.
Oh, I guess I'm a great teacher then, right?
Oh, yay.
All right. There was homework. It's kind of, in my opinion, it was kind of lame, so I just didn't want to sign it. So have a great weekend. This is your last break. Be ready to work on Monday. You made it, Bart. E-learners, if you have any questions, send me an email over the weekend. You have the same thing, no homework. I'll see you guys. We're going to go live starting Monday. So if you want to be online and get the class live, you can. I would absolutely encourage it. And then lastly, there'll be an email coming out this weekend for the accounts or the number for your Schoology account, so you can see what your homework is. So look for an email this weekend. And with that, I will see you guys tomorrow as well, or Monday. Sorry. Have a great weekend.